Do you want me to move this?
I already did. Oh, yeah.
I don't want to remember.
That's
So journal entry number 10, and the title is buoyancy. Did you say buoyancy?
Buoyancy.
All right, I know it's kind of weird. I don't know how to. I can't speak. It's fine. All right, so I have questions for you. Don't answer yet because we're gonna actually.
Wait, I have a question.
You have a question? What?
What's the date?
The date
It's 10.
is the 10th. Right?
Oh, yeah.
Number 10.
Number 10.
You have a question? What's the question?
Do we put X's there?
Yeah, if you want to. So, how is it possible that a steel ship floats? We know that steel has a density that is greater than that of water. So, shouldn't it sink? That's what we've been talking about for the past week, the things that have a density greater than 1 sink, and those that are less than 1 float. So to kind of get you guys thinking about this, we're going to do a little bit of a simulation. So instead of using steel and a cruise ship, or a big boat, I can't fit a cruise ship in here, it's a little bit difficult. So we're going to use clay as our steel, kind of to get the idea across. So the first thing we need to do is to figure out the density of the clay. So you need to write 2 FICA boxes on your note sheet. Just draw 2 FICA boxes in your notes. And this should look pretty similar to what you guys did yesterday. You guys are probably masters at this by now.
You want us to drop out some boxes?
If you want to, yeah. So I need 2 FICA boxes. And we are trying to determine the density of this clay. And now I made it into a cube shape. I did this morning. Looks pretty good. Took me a while to make it into a cube of clay. So the first thing we need to calculate when we calculate the density of something is its volume. Because I don't know what the volume of this is. So can someone please tell me what the volume formula is that should go in the first of the FICA boxes? Yes. Yep, so volume is equal to length times width times height. And you guys already know that. Now, does anyone notice my weird spray tan hands? Yeah, I look like really orange. That's from the clay. The clay is terracotta color, so it makes it. That's spray tan. You spray tan? That's cool. I do.
No.
So I didn't want to get everybody's hands all gross, so I found the length, width, and height for you so that nobody had to touch the clay and look weird spray tan. Although if I do touch my face and I get fake spray tan on my face, can someone please tell me so I'm not walking all day with like orange down my face? So I found that the length was 3 centimeters, the width was 3 centimeters, and the height was 3 centimeters because it is a perfect cube. So that should go in your information section of the box. There are calculators out on your table, so if you want to grab one. But it should be quiet because, you know, it picks up side conversations, the microphone. So if I plug into my equation, I have 3 centimeters times 3 centimeters times 3 centimeters. Now, remember, 3 times 3 times 3 is not the same. Okay, so what should the volume of the cube be based on this equation, rounded to the nearest tenth and with units? Yes?
27.0 centimeters cubed.
Yep, 27.0 cubic centimeters. Great. So we have 27.0 cubic centimeters. Now that we have the volume, we got to figure out the density. So we figured out the volume of this cube was 27 cubic centimeters. So can someone please tell me the equation for density, Lauren?
M, mass,
Yep.
over volume.
Great, mass over volume. And if you go to the information box in your FICA box, you know that the volume, which we just calculated, is what, Francesca?
27.0.
Yep. Yep, 27.0 cubic centimeters. Now, once again, I did not want everyone having spray tan hands all day, 'cause that's really embarrassing. So you guys do a lot of hand holding in this building. Whole leg. So I weighed this out for you, and I found that its mass was 54.6. What's our unit for mass? Grams. All right. So if you have your calculator, you can plug in. What should be on the top?
The mass.
54.6 grams should be on the top, and therefore your volume, the 27.0 centimeters cubed, should go on the bottom. So take time to put that into the calculator and figure out the density of the cube. Speak loud when you tell it. Raise your hand if you figured it out, and I want units. Raise, yep. Okay, so we got 2.0, and what is your unit for density? Grams per centimeters cubed. Fantastic. All right, so we just found that the density of this clay cube is 2.0 grams per centimeter cubed. Based on what you know about density and floating and sinking and hovering, should this cube float, sink, or hover? Raise your hand. And why? Austin, what should this do?
It should sink because the density is over 1.
Okay, so does anyone else have a different idea? Anyone else think it's not going to sink? What do you think?
Well, it depends on if there's air in there.
Well, I'm talking just this.
Oh.
Just a solid clay cube that we just figured out the density was 2.0. What do you think? He said sink. Does everyone agree that it should sink?
Yeah.
Yes. All right, so throw it on in. All right, what happened? It sank, which you guys all predicted it would do. If you can't see, it's a lovely ball of ugly clay sunk into the bottom. Well, I took the same amount of clay and I formed it into a cup shape. I took ceramics in high school, so I am like a pinch pot master. So, I know what's up. So, what I did was I formed that same amount of clay, that same 54.6 grams of clay, and I put it into a pinch pot shape, and now I'm going to put it into the water, and hopefully, my pinch pot is successful. Ready? Okay. So what do you notice?
Whoa.
All right, so take 2 minutes to talk with your group about how it is possible that the clay, which has a density of greater than 2, can float. Take time to think with your group and talk.
It's a pot, right?
I know, I accidentally did that.
Take another 30 seconds to talk about how that is possible based on your observations. What are your ideas? Okay, I need everybody's attention back up here, and when you answer the question, speak up loud so everybody can hear. All right, I have a couple questions before we get to your ideas. This plays off of what you guys have already learned. Does the mass of this change as I made it from this shape to this shape? Did the mass change? No. Okay, so I've got a constant mass. Did the density of the clay change?
No.
Yes. The density, raise your hand. Does the density of a material change?
No.
Raise your hand. No? Okay, explain. Why doesn't it change, Emily?
Because density stays the same no matter what.
Yeah, it's an intrinsic property. So the density of the clay itself does not change. So if we have a constant mass, how is it possible that this floats? And you should only be talking if you have something to share. So Francesca, what does your group come to about?
The reason why it's floating is because it's thinner, and I think it's because even though it's thinner, maybe because the air on the top is going in it and it's helping me float.
Anybody else have an idea about the air? Did anybody else have an idea? Nadia, did you have an idea about the air?
Well, the cube was solid, and then the bowl is kind of like hollow. So there's more hollow around.
Okay. Maria?
There's like air in the air, and then because it's like a bowl shape, it fills, because it's a part of like the air, and it makes it float, but if the water was to go over the edge, it would sink.
Yeah. Okay, so is air more or less dense than water? Is air more or less dense than water? Ian?
Less dense water.
Okay. Everyone agree that air is less dense than water? Which is kind of related to the ballast tank and the submarine thing you did, right? When the ballast tank was full of air, it floated because it was less dense. What if I put my boat in and I filled it with water? What would happen? It would sink, right? Because the density of the water, now the density of the whole boat would change. What variable did we change by making it this shape? We didn't change the mass. We said that the density of the actual clay never changes. So what did we change by forming that cube to this shape, Devin?
Volume.
Okay, volume. Anybody have an idea what we did to the volume?
No.
You don't know? You said we changed the volume. Did we keep it the same? Did we increase it? Did we decrease it by making this shape? What did we do to the volume of this entire thing by making it this shape? We increased the volume, right? We just increased the volume while we kept the mass the same. So what did we do to the density of the overall object? I'm not talking about the clay, I'm talking about the overall object. If we kept the mass the same and we increased the volume, what does that do to the density of this entire thing? Raise your hands if you have any. Austin, what did it do?
Makes it lower.
It makes it less dense. And if things are less dense and they're less than 1, what happens? What happens if we make this less than 1.0 grams per centimeter cubed? What ends up happening when I place it in water?
It makes things float.
It makes it float. So what we did was we increased the volume. The actual density of the clay never changed, but by increasing the volume of the whole thing, the density of the, right, with the air inside, actually makes this less dense and allows it to float. Similar to how cruise ships work. Cruise ships are really, really heavy, right? They have tons of weight and mass on there, but what fills the inside of a steel cruise ship, Maria?
At the bottom, there's like, they're like compartments that are just filled with air, with water on the outside.
So we have tons of air inside a cruise ship. So it's just like this, right? We have air inside here. That's why steel, which has a density of like 7.8 grams per cubic centimeter, is able to stay afloat. Because you have increased the volume, you've added air, and now the density is less than 1, and you're able to keep it afloat. Pretty cool that you're able to change the density of a system by changing its shape. All right. Do you have a question?
No.
No? Good? Okay. So, we've been talking a lot about floating and sinking. I'm sweating profusely. I wore this because I just didn't want to get stuff all over my clothes. But we've talked a lot about floating and sinking, and there's actually a specific word that we use when we talk about a tendency of an object to float, and that's called buoyancy. And you're going to want to get that down. So you're going to want to get the definition for buoyancy down. And your eyes should be up here, not crossed. So buoyancy is the tendency of an object to float. We've been talking a lot about floating and sinking, so this is the actual term that we just use to describe when an object is floating or sinking.
We were doing that.
Yep, you can write everything down if you get stuck in that. So buoyancy is the tendency of an object to float. Another way we think about this in scientific terms is the upward force. So upward force, if you're like picking something up, you lift weights, you know, you get buff in the bathroom. So upward force exerted by a fluid. So in the case of our little clay boat, the fluid is water. So
What's the definition?
this is kind of like both, if they fit into one another. So an upward force exerted by a fluid on an object, in this case our object was a little clay boat thingy, that is partially submerged. When we set this in water, does it just sit like this on top of the water? Does it just sit like perfectly on the top? No, some goes down, right? So it's partially submerged. So upward force exerted by a fluid on an object that is partially submerged. And it's a tendency of an object to float. So we're going to kind of like draw this out so you can have kind of a visual to see how this works. If we have a boat, this is an object that is partially submerged in a fluid, right? Water is your fluid, you got an object, the boat, and it's partially submerged. Which direction does gravity pull on the object? Does the gravity go this way or does it go this way? Which way does gravity act on the object? And if your hand's not up, you don't know which way gravity acts yet. It goes down. So the force of gravity is acting this way on the boat. So we've got something pulling the boat down, but then how is it staying up? If we got this huge force pulling down, then what is going on?
Because of the air, it's like keeping it pulled up. Because it's like, because the water, like since the gravity is going into the water, if water went into the boat, it made it sink. So the air makes it sink.
So which direction is the force of water acting on the boat? Yeah.
Pushing away.
Pushing down, up, which way?
Kind of going like this.
Okay, so this way you're kind of saying,
Yeah.
you're going like this.
That's the resistance of water which pushes it up.
Okay, so the resistance of water, you're saying to counteract this, it's got to go up, right? So this is the buoyant force.
We have to draw that picture.
You didn't have to, you can draw like a little circle in water, it doesn't matter. So we've got gravity acting down and a buoyant force acting up that's keeping the object afloat. Now in order to keep the object up, the buoyant force must be greater than the gravity, right? If gravity is pulling down enough and it's greater than this, then it's going to sink. For example, when we fold this with water, the buoyant force over is not big enough to hold it up because the weight of it is too great. But when it's filled with air, the buoyant force is greater than the gravity and it's able to float. So buoyancy can be related to density too. If you have an object with a high density, so we're going to say like greater than 1.0 grams per cubic centimeter, does that object float or does it sink? Raise your hand. Does it float or sink? And if you don't have your hand raised, then you have no idea what an object greater than 1.2 grams per centimeter cube or something like that would do. Yeah. It's going to sink. So high density means it's going to sink. And if we're saying that buoyancy is the tendency of an object to float, then something with a high density will have a low buoyancy. Sometimes they say low buoyancy, they say negative buoyancy. You might have seen that in your article about the submarine. They said negatively and positively buoyant. If it says negative buoyancy, that means low buoyancy, which means not that easy to float. It doesn't tend to float. What about an object that has a low density? Does it float? Does it sink? What does it do?
It floats.
It floats. So a low density means it's going to float. That means that it has a high tendency to float, or a high buoyancy. And we call this positive buoyancy.
What's this a neutral?
Neutral buoyancy is when it hovers in the middle.
Did you say neutral buoyancy?
Yeah.
Did you bring that term up, or did you?
You just did.
Oh, it's a good term.
Neutral buoyancy,
I didn't pick it up.
did you read that in the submarine article?
Oh, yeah, that was John.
Submarine article, so neutral buoyancy is when it just is hovering in the middle, which would be like 1.0 grams per cubic centimeter if you're in water. So everyone got this down? Mm-hmm. All right. So, let's go back to our idea of cruise ships or big ships, because this is going to relate to what you do tomorrow. So in order for a cruise ship or some big object to float in water, it must displace. What's another way to think of displace? You guys have used the word when you figured out displacement. Push aside, so that helps you. So in order to float in water, an object must push aside an amount of water equal to or greater than its weight.
That means either a neutral buoyancy or a
It'd be a positive weight.
or a neutral.
Neutral would mean it would hover in the middle.
Yeah, like it's equal.
So we have, in order to float in water, an object must displace an amount of water equal to or greater than its weight. Do you have a question?
How do we?
How do we float? We displace water.
Yeah, our density is about exactly 1, too, which is when you take a deep breath, your density will get less than 1. That's why if you breathe in deep, you go up. Do you ever notice that? And then when you exhale, you go down a little bit. Yeah, we got to rock, though, because these guys are done at 48, so I'm going to have to grab a portfolio from them. I think we're in good shape to
This will
build
set
this
you up
thing
for
tomorrow.
tomorrow.
Oh, yeah, definitely. I think we're in great shape. Okay, so here's what we got going on now. We need to quickly, we'll hit it next time, no worries, no rush. But here's what we do need to do. We have to total this portfolio. Because we only have about 3 minutes left in the class period, what I'm going to do is I'm going to total it in a very easy way. I just need you to get the pages out and get yourself ready to go. Cards should already be out on the table, so if you can get that going quickly, you'll be all set. Brain pop, I'm sorry, the portfolio is 3. We're going to do brain pop sub. Make sure you write down your grade. What we're going to allow you to do for now is simply, if you have the page, you can, for this right here, you have a grade on it. I'm going to have to hold them a little bit, so if you have sound, don't worry. Make sure you got cards and stuff. Big piles for kids who are not here, please. All right, we got brain pop on the submarine. That's the grade is written on it. Then we've got, can't remember. Oh, density activity from yesterday. Now, hold off on your grading of these ones. This one you can put the grade on, the other ones just hold off. We got the density. We've got your bubble map. We'll call it sub bubble. And then we have journal number 9. That's not a 9, that looks like a P. We have journal number 9. Now, here's what we're going to do with these pages. We're going to keep this real simple because of the time that we have left. This right here has a grade on it. You've already written it down. You shared that grade with somebody else. For each of these, if you have the page, give them 10. If you have the page with you, give them 10. So these ones right here, yes, those 3 pages, that's fine. Okay? And I'm happy to say that you all have, everybody in this class has a 20 on 20 on the mini-most, so we don't have any issues along those lines. Nope, you're good. Just take it. Just take it. So you can take the 10 just because we need to get going. It's the difference between 1 point. That's why I don't care. It's fine. Yeah. You can take a 10 on the journal, too. Okay, that's fine. For the quiz has been handed back to you. Make sure you record it. The quiz is handed back. You're going to add, and then you're also going to put it where it says journal number 3. So you have absolutely everything you need. I just inflated your grades by 2 points, and it doesn't matter. That should be 9. Yeah, except for the brain pop. Brain pops are great. Brain pops, whatever your grade is, the other ones, if you're at least coming up with them, it's fine. You can take a 10 on them. Portfolio number 3, I will help you. Get your right here. You would stay in here? Okay, you know your first grade condition. If you were with me in here, if you were with me in here yesterday, and for the last period working on your quiz, you know your quiz grade, and you can just write it down, because you still have it. We're not on block. I'm just going to hold you for a minute so you're not all stressed out. All right, I'm going to leave you with a couple instructions. You need to make sure that your portfolio is totaled and you put your portfolio card on the clipboard. All the other pages, if they've got holes in them, put them in your binder. If they don't have holes in them, throw them out as you leave. Got it? Okay, so you put a big old 0, then come put your
Just how much you got in the Just how much you got in
Whatever you can fill out, my friend.
We gotta hurry. I'm starting now, so be ready.